Okay, I just want to take a quick video because all the videos I'd found on YouTube didn't have what I was looking for. I do a lot of plastic welding with polycarbonate. As you can see, I made that little thing. That was one of my very first projects with polycarbonate, but I use a lot of polycarbonate in my work. But polycarbonate is easily identifiable because it's usually quite clear, quite transparent, and it can be bent at a sharp angle without breaking. Acrylic is also quite clear, but it would break if you were to try and bend it like that. So that's your polycarbonate. Now that doesn't come in your Harbor Freight crappy welding sticks. What you get with those is ABS, PVC, and polypropylene. Another one you don't get in the quantity sticks of Harbor Freight junk is nylon, and that's what I also use a little bit of, is nylon, and that's why I have these zip ties right here. Zip ties make great nylon plastic welding bits. Now, to try and describe, the thing I needed to find on YouTube was helping identify what question mark material this was. There's no markings at all on this piece, this item that I'm trying to repair here. There's a auger that runs on the inside of here, and it wears out a hole on the side of this over time, and I've sleeved it with a stainless steel sleeve, but I still wanted to fill in the hole just to make it so that it would be a little bit stronger, because I have another one that almost broke clear off. This little neck here almost broke clear off, and I had a hard time trying to figure out what kind of material this was, what kind of plastic this was, because there's no markings on it whatsoever, and it didn't fall into my category of 5 different kinds of material there. So I did a little bit of research, and I couldn't find anything that showed it melting. None of the videos on YouTube showed what different kinds of plastic look like when they melt. So I'm going to do a little quick demonstration. I have the Harbor Freight welding, plastic welding tip thing here, and it's running through a regulator, yada yada yada, all that crap. And I just wanted to show a video of it melting. This material, when it melts, it changes from opaque to transparent, and it becomes kind of sticky. It doesn't really liquefy, but it becomes sticky. And so you can see that here. It starts to turn kind of a golden brown, and it will start to get sticky and dewy, but it won't stick. The polypropylene and the ABS rods that come with your Harbor Freight junk set won't stick to it. Neither will the polycarbonate or the nylon. None of those will stick to this stuff, whatever this is. And so I did a little bit more research, and one of the other common thermoplastics is HDPE, signified by HDPE right there. So this is a milk jug I've cut up into strips, about 1/4 inch for my American friends, about 6 to 8 millimeter for my metric geniuses out there who use the metric system, which is much more efficient. So anyway, I'm going to try and melt these two together. I'm not sure if this is HDPE, but I think it probably is. I'm guessing here. So I'm going to take one of my strips of milk carton, and I'm going to try and melt it together with this other stuff, see if it sticks. We're going to reheat that, get it softened again, and then we're going to cram some of that stick into it. Sorry for the shaky video. I don't have a tripod or anything, so I'm going to try and use 2 hands to use this. So I have my Harbor Freight thing set up on the highest setting it goes to, and we're going to try and melt this into it. I'm a horrible videographer, but as you can see, the milk jug also turns transparent. It goes from opaque to transparent. It's like this mystery material. That's what made me think that maybe they're the same, is that one quality, they turn from opaque to transparent, got me thinking maybe they were similar. So here we go. I'm going to try and hold the same hand with the welder as the phone here. And it looks like it's sticking. It looks like it's sticking pretty well here. But the thing with HDPE is it doesn't like to liquefy. It likes to be under pressure. So we're going to take this other metal rod I have here. We're just going to smash it together. We're going to heat it up a little bit, and we're going to smash it. Because HDPE doesn't really, it likes to be extruded. It seems it likes to be pushed. It likes to be pushed, heated up, and then pushed into stuff. So we're going to push it together with this plastic metal rod and see what happens. And that, my friends, is the best looking joint I've made with this mystery material out of anything I've tried. I've tried a lot of different plastics to fill these holes, and the closest I've found so far is this milk jug this time. And you got to witness the very first successful joining of this stuff. The only other thing I used to be able to do is I would go over here to this hole. There's a hole over here, and there's a shaft that runs through it. But there's a big housing, there's a big bolt flange, and so it's sealed all the way around, a big, like 6-inch hole. But they only cut a little bit. So the other thing I was doing was I was carving it out. I was using a fox knife, and I was carving out little bits of this plastic and melting it back to itself. And that seemed to work quite well also. But I couldn't figure out what kind of material it was with my 5 common mixes of materials. So it looks like HDPE. And as you can see, HDPE turns kind of clear when you get it hot. That's the one thing I wanted to show on this video. It turns clear. HDPE often is a color, and it turns more transparent. It's a color or a white, and it turns more transparent when it melts. That was my goal in doing this video. For those of you who are curious, I will also do another video shortly showing what these other 5 common melting plastics look like, these other thermoplastics, what they look like when they get heated. Because they all have a little bit different properties, and they all look a little different when they melt. And I think that would help a lot of people who are DIYers and whatnot figure out what they're doing. Is if they can see something that doesn't have a clear marking on it of what it is, they can figure it out by looking at its properties. How does it melt? What temperature does it melt at? Does it burn? Does it char? What's it look like when it melts? And so all of these materials do a little bit differently, and they don't stick together. None of them stick together. They might barely stick together, but they'll pull right back apart. And so that's why I wanted to make a video. I will make another video shortly of that.